Good afternoon, everyone. Welcome to our automotive webinar. I think we have 2 o'clock and we start on time. Quite a good number of participants already, so I think we can start. My name is Frank Eisenträger. I'm responsible for market development in EMEA Starolution in Europe, and I'm your host today. With me, there is Knut Seibel. He's Market Development Manager, especially for automotive. And he will actually do the main part of the webinar. I will then jump back in for Q&A. And talking about Q&A, you can post us at any moment in time questions on the Q&A button, which is somewhere in the upper right. And we will then read out your question at the end of the webinar without mentioning your name, because this is a recorded session. Nevertheless, it can make sense to leave us your name, because then we can follow up even after the webinar on that question. I checked the list of participants, and I think everybody is well familiar with EMEA Starolution already. So actually, I will skip the introduction of the company. Nevertheless, I wanted to give you a quick overview on what we do in general regarding sustainability. I mean, you know that we are the leading supplier of styrenics in Europe as well as globally, but actually our ambition is also to lead in sustainability. That, of course, starts with our own commitments, and there are quite a lot of measures we will implement regarding footprint, leading to net zero in 2050. But there are really many measures, many milestones, and the one which is amongst the first that we have already implemented is that all our production sites in Europe have switched to green electricity. But then I also want to give you a quick glance on what we do also in other industries that can be of interest. And regarding mechanical recycling, we do recycle polystyrene already back to food contact. This, of course, requires a lot of sorting and a lot of cleaning steps and a lot of communication back and forth with the authorities. But I can tell you we managed it, and PET is no longer the only one which is back to direct food contact. Next one, where we see already larger volumes coming up, is in household and electronics, so in fridge recycling. Also there, we introduce our material expertise to help with solutions, because you can imagine a fridge after 10 or 20 years lifetime, the plastic materials have quite degraded, and we need to upcycle the materials back to the properties needed for a fridge. And I think pretty much the same is true for automotive. I mean, automotive is still small, I think, but the challenge is the same. So we really need to upcycle the materials to the high property profile which we have in automotive, if you think about VICAT or impact or emissions or absence of specific elements. Another topic, and I want to introduce you quickly into that, you'll hear maybe a little bit more of it, is sustainable feedstocks. So, for example, we can introduce, instead of a fossil feedstock, a bio-naphtha or biogas, or my favorite feedstock actually is used cooking oil, just in replacement of the fossil feedstock. So this leads to exactly the same materials and exactly the same material properties, but at a very different footprint. This is a development, or this is something where we are really strong already with larger volumes in the toys industry. Another one coming up is depolymerization. This is a special sort of chemical recycling, I would say. That leads us back to recycled styrene monomer, how we call it. And this then can be introduced for any material that we produce, be it ABS, ASA, or even more complex compounds, and we can use it in all industries. And I think Knut will go into a little bit more detail on that for automotive. So with this, I would say I'm ready to already hand over to Knut. He will lead you into the details of our automotive offering, and then I'll see you back in Q&A. Thanks.
Okay, so also welcome from my side. In the next half an hour, 45 minutes, I will guide you through our eco offering for the automotive industry. And first of all, I would like to talk a little bit about what eco sustainability means for us. We have two major targets, which are, let's say, require different measures as well in the way how we tackle these targets. One is avoiding littering and waste, so keeping plastic out of the environment. This is a part of recycling. Very important to mention here, for all grades where we are talking about recycling, which I will present in the next minutes, we are talking about post-consumer waste recycling. INEOS Styrolution does not offer any post-industrial waste recycled grades. This is for availability reasons as well as for, let's say, sustainable reasons. Second part is the CO2 footprint, CO2 emissions. This is, of course, linked as well to recycling. If you use a recycled feedstock, you bring down the CO2 footprint of your product, but you will never become net zero with recycling plastic materials. So in order to become net zero in terms of CO2 emissions, you need to take different measures like the bio-based feedstocks or renewable feedstocks Frank was mentioning in the introduction. Sustainability is not new for us. For more than 10 years already, we are being rated by EcoVadis, and we developed our rating ever since then. At the Care Fair in 2019, we presented the first mechanical recycled ABS, and the same year we had the first trials in automotive application with these grades. In 2020, we introduced bio-attributed grades, especially for ASA application or for ASA materials and for chrome-plated application. And in 2023, we had the first mass-produced components in automotive application with a post-consumer recycled ABS. And this year, later this year, we will be able to introduce ASA and ABS based on depolymerized styrene monomer, also from post-consumer waste. Recycling technologies. Basically, for our products, for our styrene-based products, so ABS, ASA, and the blends we are producing, we have three major loops, let's say, where we recycle our material. The most simple, but most efficient recycling loop is the mechanical recycling. So we sort material, collect materials, sort it, recompound it to a recycled ABS, for example. So we stay on the polymer level. This has the best CO2 footprint and also the best time to market. We are already there. We have it in the market. The second loop is the depolymerization. This is something a little bit special for styrene. So we can recycle polystyrene, or we can depolymerize polystyrene to styrene monomer and then use the styrene monomer for the polymerization of SAN, for example, and compound ABS from it. So we stay on the monomer level. And then the biggest loop, let's say, is the pyrolysis of mixed waste or end-of-life tires, for example, which bring us back to something naphtha-like that we can then feed into a steam cracker, get the basic chemicals out of it, go to the monomer level, and then start to polymerize products from this level. Another additional stream comes in here. These are the renewable feedstock, which also like bio-naphtha, biogas, used cooking oil, which go to the steam cracker, and then we take the basic organic chemicals from there. Our offering at this point in time, so for all these three classes or kind of sustainable approach, we have an offering. We have mechanical recycled high heat ABS for automotive application. We have Novodur high heat ABS. We have Novodur P2MC for chrome plated application, and we have our Luran S ASA material for uncoated exterior application, for example, based on biofeedstock available. And we have available the same products, so the Novodur high heat grades ABS, Galvano grades, and the ASA grades based on advanced recycling, so the recycling of either end-of-life tires or as well later this year the depolymerization of polystyrene waste back to styrene monomer. I will go in the next slide. I will go a little bit deeper into the mechanical recycling as well into the advanced recycling. We will not go into detail on the biofeedstock because this would be probably too much for the 45 minutes we have today. So we start with the mechanical recycling. The source for our mechanical recycled ABS is WEEE, so household electronic equipment. If you are in EMEA buying a new computer, a new coffee machine, a new printer, your dealer is obliged to take back your old device, and this is the source for our ABS, recycled ABS grades. So these electronic waste will be collected, dismantled, sorted, shredded. Then you have the washing, sorting of the flakes, and these flakes then are the source for the compounding of our recycled ABS. Very important on the slide, you see recycling content up to 70%, which is true for a Teluran, a grade that is used, for example, in the coffee machine housing. But this is not true, unfortunately, for an automotive ABS, because when it comes to automotive, we have we have two challenges. We need to recycle an ABS, compensate the loss of properties from the, let's say, first life of the product, but we also need to bring the material, which is, let's say, in household ABS, to the level of an automotive ABS. So it is rather an upcycling than a recycling. And this is limiting us in terms of recycling content to 30 to 40% of recycling content in our automotive products at this point in time. Here we have the overview about our products. We start, the logic for all the products is that these products have a sibling, fossil-based sibling. So these are well-known grades, Novodur HH106, Novodur H605, Novodur H801, and Novodur Ultra 4255. These are grades that are in its fossil-based version well introduced and used for many years in high volumes in the automotive industry. And we have developed the recycled siblings to these grades to have a drop-in solution with performance that are comparable to the fossil-based version, and which also gives you a little bit of security as a backup. So if you have a product or a component validated in an eco grade, you would have a fallback position in a fossil-based version, which was at the beginning of this development of the recycled ABS grades, very important, very important for the automotive OEMs to have such kind of backup solution. So if we go through the grades, first grade is Novodur Eco HH106 MR30. So nomenclature-wise, Novodur Eco is an sustainable ABS, and the MR30 suffix, MR stands for mechanical recycling, and 30 indicates 30% of recycled content in this grade. So Novodur HH106, it's a typical grade for exterior application, covered exterior application like substrate moldings for such kind of exterior pillars overmolded with PMMA, components in a mirror, housing internally, for example. Yeah, any kind of covered structural part in exterior applications, not suitable for interior because of emissions, but this is the case for the fossil-based HH106 as well as for the eco version. Has a relatively high Y cut, but not the highest impact strength and also not the highest flow. Novodur H605, Novodur Eco H605 MR30. That's a quite simple but easy to process material, especially for interior applications. All components in the lower area of the interior, like seat trims, door pockets, yeah, components in the seat area, cover for these ISOFIX fixation points, things like this, as well for painted application. Same, it doesn't have the heat resistance as an HH106. It is more or less in the same area of impact strength, but it has a very high flow. And this is what makes the material yeah, quite unique. It is excellent in processing and yeah, solves very often quite a lot of molding issues because of the good processability. Novodur H801 and Novodur Eco H801 MR14, mechanical recycled ABS with a PC modification. Here you see the focus is definitely on the impact strength. It's a material with a high impact strength, room temperature, as well as at -30 degrees. Bicut or heat resistance in the same area as the HH106, but not the flowability of an H605. Last but not least, our, let's say, most recent grade, the Novodur Eco Ultra 4255 MR30, which is at this point in time still running under a so-called BX number, so a development number. This is a ABS PC based on recycled ABS. So not the PC content is mechanical recycled, it's the ABS content in here. Material with a very high Y cut, very high impact strength at room temperature as well as at -30 degrees, and the high flowability. So this is the, let's say, the best in class material in our Novodur Eco range, where we just started sampling to customers and the validation process or validation work to get this product validated at different OEMs. Again, to mention, the mechanical recycling provides also an improved or lowers all of these mechanical recycling grades have a lower CO2 footprint than the fossil-based versions. But this is, as I said before, this is not the main target of these grades. The main target is to close the loop, to bring back material that have been in the market back to a new life. But we, of course, take the advantage that it also reduces the CO2 footprint. This is a short overview about, a very condensed overview about the targeted applications and as well about, to give you a rough idea what OEM norms we are targeting with these grades, or we already have, let's say, the grades tested and validated. The Novodur Eco HH106 MR30, as I said before, typical material for exterior components, rear light housing, pillar inserts, any kind of structural part in exterior, meeting the requirements of the TL 527A, for example. It is listed at the secondary raw material list at BMW, and we also fulfill the requirements of the, let's say, new Mercedes-Benz DBL for, let's say, uncoated or non-visible parts. Novodur Eco H605 MR30, material for interior application. This material does fulfill interior emission requirements, same as the virgin or fossil-based product. And it's important to say if the product is a low emission product in a fossil-based or virgin version, it is as well low emission product in the eco version. So typical application are, as I said before, uncovered interior application. We are able to do color matches for this product, so to match typical OEM colors. In the first step, preferable dark colors. We are limited due to the nature of the feedstock, or the, let's say, natural color of the recycled feedstock. We are limited in a certain way. We are not able to match the brightest colors and also not to match the deepest black. And this is also a topic that needs to be discussed. Needs to be discussed with each OEM separately, if they accept certain deviations or if they are, let's say, insisting on the color target they have for the virgin product. We do this work currently for all, let's say, major OEM colors, especially the major dark OEM colors at this point in time. But it is, sometimes a very complex discussion with the OEMs to match this color. They are challenging us, of course, how far they can push it, and we try to get the best compromise between what is possible to produce, also from a commercial point of view, and what can we do to meet the color targets from the OEMs. Novodur Eco H801 MR40. One big portion or one big application for this product are definitely the bumper brackets and exterior, so the structural parts that are sitting behind the polypropylene bumpers, but as well as interior covered components like parts in or components in door panels, top rolls, fabric or leather wrapped, and other interior components painted or covered. Also, this material is a low emission material. And last but not least, the Novodur Eco Ultra 4255 MR30 ABS PC. Same for interior application, covered as well as uncovered application. For example, we are targeting here the typical interior pillars, grained pillars, upper and lower pillars, in some cases as well with airbag chute requirements. Here we are currently in testing to see if we fulfill all the requirements of the OEMs and to also get it listed, for example, at BMW in the secondary raw material listing. Talking about the CO2 footprint, as I said before, not the main target or not the priority number one for these mechanical recycled grades, but they do offer quite a nice CO2 footprint reduction. You see that we are in the area of 20 to close to 30% CO2 footprint reduction. Very important to mention here, the figures I'm showing on the slides are not considering things like avoided incineration. So we are really comparing here the CO2 footprint of the fossil-based material to the material where we take, let's say, the mechanical recycled feedstock as zero in terms of CO2 emission, plus the efforts we need to take for collecting, sorting, and compounding of the material. And this is creating the delta of 20% for 30% containing recycled ABS product, for example. Very important topic, and I've shown some of these slides already to various customers and OEMs. And one of the biggest discussion or one of the biggest concerns we always hear is the batch-to-batch consistency. We understand that our customers are concerned about the consistency of a mechanical recycled ABS, and we also know that there are products which are, let's say, not very stable in terms of the product performance or product properties. In our case, it's important to mention that we produce all our recycled Novodur Eco grades, so the mechanical recycled grades, on the same production line as our fossil-based grades. So there's no difference. We don't have a specific production line or a specific production setup for our eco grades. For our production, it is just another product with a different feedstock, but they produce it on they will be compounded on the same line, and we apply the same quality measures to our mechanical recycled material as we do for our fossil-based grades. And due to this, you also receive the same kind of quality documentation with every batch of mechanical recycled Novodur Eco ABS as you are used to already for our fossil-based materials. I've collected some results. We have the Novodur Eco H605 MR30, and we have the Novodur H605, the fossil-based version. These are production statistics collected over 2 years of production, and you see the Y-cut. This is the Y-cut E120. You see the Y-cut values for each batch. The big dotted line is the average Y-cut over these 2 years, and the light dotted line here is the lower tolerance for the product, which you also see on our quality certificate. And as you can see, if you compare the eco version to the fossil version, they are both in the same level of Y-cut. They are both comparable in terms of batch-to-batch variations, and they are both quite far away. There's a lot of tolerance still to the lower tolerance limit. The same diagram for the notched Sharpie at room temperature. Here it's important to mention that, of course, the average as well as the lower spec limit, lower tolerance for the eco product is lower than for the virgin product. This is due to, let's say, the nature and the quality of the WEEE feedstock. We are not able, in terms of an H605, to meet the same Sharpie level as we do with the virgin product, because in this particular case, the focus was the development of this product was to keep the high flow of the material. And this is what I showed a few slides before. Focus here is the higher flow. So we have sacrificed a few kilojoule per square meter on Sharpie, on impact strength, but still on a high level. And as you can see here as well, this is produced on a very constant and stable level compared to the fossil-based version, which are, in my opinion, comparable. So we are able to produce these grades to the same quality and to the same consistency as you are used to receive from our side from our well-introduced fossil-based products. Okay, moving to the next product or to the next recycling technology, which is the advanced recycling. All we are doing here is based on a mass balance approach. And we have, as I said before, we have different, let's say, recycling loops. The standard product, if we're not talking about recycling, the standard production chain would be you come from the oil, fossil or oil or natural gas, goes through the refinery, get out of the naphtha out of it, which goes to the steam crackers, from which we take the basic organic chemicals that we use for the polymerization and then the compounding of our products. You can replace the fossil-based or the mineral oil or natural gas with a biocircular feedstock, which then goes through a refinery. We get bio-naphtha or biogas, which then goes to the steam cracker as well, from which we take the basic organic chemicals. Next loop would be the pyrolysis of mixed plastic waste or end-of-life tires. So you have the pyrolysis oil, which then will be fed to the steam cracker as well. And last but not least, the depolymerization of styrene or polystyrene post-consumer waste. Here we don't go through the steam cracker any longer. Here we stay on the level of basic organic chemicals, styrene monomer in this case, which of course is a huge improvement in terms of CO2 footprint, because we don't need the energy for pyrolysis and we don't need the energy for the steam crackers. We stay on the monomer level and don't go back to pyrolysis or naphtha. All of these technologies, so biocircular feedstock, depolymerization, or pyrolysis of waste or end-of-life tires, have in common that we are using a mass balance approach for it. So they all go through the same production, and they all go into the same polymerization reactor, and we use the mass balance approach to assign the level of sustainable content for the product, depending on which product we are selling. The big advantage here is on the product itself, you don't see any different to the fossil-based version. So it is the identical product. The only difference here is basically the printing on the back, and at the end of the day, also the price tag for the different products. As we already mentioned before, we have an agreement signed with a provider who is doing the depolymerization from post-consumer waste polystyrene waste, and from this production line, this industries scale production line, we are able to take the styrene monomer, which we can use for the polymerization either of new polystyrene or as well for polymerization of SAN that we can use for the compounding of ASA or ABS products then later. Production here is already in the ramp-up phase, and we will be able to offer products here by the end of the year. This is quite nice in terms of CO2 footprint reduction. Here I'm showing the CO2 footprint, or to compare the CO2 footprint of the styrene monomer, of fossil-based styrene monomer versus a styrene monomer from the depolymerization. The total level of CO2 footprint reduction depends on how much styrene does the product contain. So there are typical automotive grades are in the range of 40 to 60% of styrene in the product. You can calculate based on this how much CO2 footprint reduction you could achieve then on the different products. Same here, this figure is 50% reduction on the styrene monomer, does not contain any contribution from avoided incineration, something like this. So we are really comparing the CO2 footprint for the virgin or fossil-based styrene monomer to the CO2 footprint for the styrene monomer from a depolymerization. So we take the feedstock as a 0 CO2 footprint plus the additional efforts we need to take to depolymerize the or to collect and then depolymerize the polystyrene waste back to styrene monomer. If you would consider avoided incineration, you could achieve much higher figures, but in my opinion, this is rather a marketing tool than a real scientific approach where to compare different products. Okay, this brings us already to the summary slides. We support the OEM sustainability targets, or the sustainability targets of the automotive industry in general. We are already now able to offer CO2 footprint reduction of 20 up to 70%. This depends on the measures. So coming from 20%. We are talking here about a mechanical recycled ABS, and we can also offer products with a bio-based content where we go up to 70% of CO2 footprint reduction. We also have further activities in place. As Frank already mentioned during the introduction, all our production sites in EMEA are switched to green electricity. And we have the ENEOS 1 project, which is a new H2 powered steam cracker in Antwerp. This is currently under construction, and this will then also will be a big contributor for feedstock with a significant lower CO2 footprint than the conventional feedstocks that we, or as well as the whole chemical or plastic industry, are currently using. Regarding recycling content, I mean, you all are aware about the current end-of-life legislation draft. Here we are talking about 25% of PCR, post-consumer waste content, in 2031 or 2032, and this should include additional 25% of these 25%, so 6.25% in total, should come from a closed loop automotive recycling. We are already now able to offer recycling content of 30 up to 60%. When we're talking about automotive, we are rather on the 30 to 40% side. This is because, as I mentioned before, we're not doing only the recycling, we have to do this upcycling from a WEEE waste to an or WEEE applications to automotive application. This brings us to our current constraints and challenges. So at this point in time, this household electronic waste is the only source for our mechanical recycled ABS. And as I mentioned before, for us, it means we need to upcycle this material to meet the automotive performance standards. And the challenges we have, we as ENEOS Dilution, but also we as automotive industry along the whole supply chain, we need to find ways to access waste from end-of-life vehicles in order to be able to meet these 6.25% requirements in 2031 or 2032. What we can offer right now already is to encourage you to work together with us on lighthouse projects. So to try to develop products, to try to get a better understanding on what is the right way to recycle components from end-of-life vehicles. Is it really the mechanical recycling? Are there other technologies that are better? And we also need to start actually working on it to understand what technical challenges and constraints we have. How much does a end-of-life vehicle waste needs to be pre-sorted to be that we can compound an automotive, or that we can recompound it to a recycled ABS that meets automotive standards, but which is also commercially attractive. This is the key. You can do a lot, but it also at the end of the day needs to be economic, and we need to be able to do it in a way that the automotive industry will pay for a product like this, which is important. That leads to the next topic. All our sustainable efforts at the end of the day, they need to be profitable to be sustainable. We as a supplier of this material, we need to be able to, at the end of the day, earn money with a product like this to bring a sustainable product in the market. And this is a market that needs to be developed from a commercial point of view as well from a technology point of view. And also a question that comes up very often is the question about the feedstock. Do we have enough PCR feedstock available to serve the automotive industry? And the question here from our side is yes, based on what we know. So we have a dedicated purchasing team dealing only with recycling feedstock. And these guys are doing their forecasting and their work, or they source the feedstock based on the forecast they're receiving from our automotive team. So if we know and if we have an idea about how many eco product will be needed in the next 5, 10, 15 years, the better we know what we can expect, the better our colleagues from purchasing can do their job. So, and what I want to say with it is we need to talk about it. We need to stay in contact. We as a material supplier need to talk to the OEMs as well, to the molders, the tier ones, to understand what do you need, what do you expect from us, and what are the volumes you need to source in the upcoming years, so that we can do our homework and take care about the feedstock. As I said, based on what we know, we are safe, but I don't know if we really know if we know everything, and if there may be a higher demand than what we currently see. Okay, this was actually my last slide, and then I will hand over back to Frank for the Q&A session.
Excellent. Thank you, Knut. I think that was a quite extensive overview on where we are regarding sustainability in automotive. And we are good in time, so we have time for several questions. And I see already the first being in the system, but I, of course, want to encourage you to further ask questions, and then we try to tackle them. First question, do you also have post-industrial products? And I think this question I hand directly through to you, Knut, again. So post-industrial within your solution.
Yes, as I said before, we do not offer post-industrial grades. This is mainly because of the availability. You need to imagine that the source for post-industrial grades are off-spec materials. So the off-spec materials, for example, we are producing when we start a compounding line, for example, or also the off-spec parts of a big molder who's molding, for example, big door panels. They are being collected and then recompounded by the typical post-industrial waste compounding companies. This material, there is a reason for this material, and it is better to recompound this post-industrial waste than to put it to incineration. But these grades are limited in availability because neither we nor the molders have any interest in increasing their output on post-industrial feedstocks, which is basically scrap. We are trying to reduce our scrap rates. Same for all molders, they are trying to reduce the scrap rate, and this is the source for post-industrial waste. So there's a huge mismatch between increasing demand on one side for recycled products and the feedstock post-industrial waste, which is in principle industrial scrap, where everyone tries to reduce this level or this percentage as much as possible. So for this reason, there's a reason for these grades, but this is not the solution to close the recycling loop in the automotive industry.
But maybe let me add here, we are also not sure yet if the post-industrial waste will be accepted in the regulation to come. So therefore, yes, we are careful on that one. And currently, we focus on post-consumer, and this for us is on a good way, and this is currently our strategy. Good. Then I take the next one. You mentioned, Knut, that goes again to you. You mentioned drop-in solutions, but I assume to the other name and other mechanical properties, there's the necessity to sample and approve it as a new one.
At this point in time, yes. So this is this question we need to push back to the automotive OEMs basically, but from the workflow at all OEMs we are working with, we have to say that these would require a new validation. That's true. This is the big advantage of the mass balance approach. So if you have a product already in running business, for example, like a interior pillar in a Novodur Ultra 4255, which is validated and tested, you can switch it to a Novodur Eco Ultra 4255 MR30 because the product is identical. When it to a chemical recycled product, because the product would be identical, and most probably it's just a front page PPAP.
So then there are two questions which I think belong together, and I can take them. So the first was, do you offer your grades only in black, or do you already offer colors? I think we even mentioned it in the presentation. Yes, we also do colors, different colors. Of course, very clear colors are more difficult than the darker colors, the usual thing about recycling. No? But then the next question, for new OEM color match requests, is there a minimum annual volume demand threshold? And if so, what is it? I think we are in close cooperation with our distribution partners. So even if for us it is below the threshold, then our distribution partners would kick in and basically approach us, and we will make everything also in the eco portfolio to supply you this in color. And new color match request, that's also actually, I hope that most of the colors we already have matched, and then it would be just a transfer from an existing fossil grade to the sustainable eco grade. So good. Another question, very interesting one, is the depolymerization styrene mass balanced? I think I take this one as well. Actually, when we buy it, it is 100% recycled styrene coming only from waste, and it's not mass balanced. But then for us, the issue comes that our installations are much larger compared to the volume of the recycled styrene, and therefore we actually have to mass balance it. But that's just that is not to introduce it to 10% recycling content only, or whatever reason. It is just because the feasibility in our production assets. Good. Then one question: what are the values of the factor emissions of each grade with mechanical recycling? I think that is a more difficult question. So currently we don't publish the footprints, for example, per grade. We do this in bilateral discussions, and for that it's actually good that we have your name, and then we can come back on this individually. And I also want to encourage everyone, if you want to discuss footprints or whatever with us on a specific grade, then just approach us. And I think that is also that is the current situation. I think in the future we will also publish those. That will come, but it's not yet the point of time. Another question: so you don't have anything in ELV closed loop for automotive? Knut, I'll give you that one first.
Yeah, we don't have it because we don't. There is no source for ELV waste at this point in time. And this is something that needs to be developed. The question: what is the right way to recycle an end-of-life vehicle? Basically, there are already these. I don't know the English word for it. Schredderleichtfraktion in German. So basically, you shred a car and take out the metal and everything that's not metal. This is what you can get back. These kind of feedstock is already. There are companies who are doing sorting of it already, but they are at this point in time they are only interested in the polyolefins. So they do a sink or swim sorting and take off the polyolefins, and everything that sinks down to the ground of the tank goes to an incineration. But basically, this is what's at the bottom of this tank. There is the material in what we would like to recycle, and yeah, this is what needs to be developed. And it's also a question, what I said before about the commercial aspect of it. Does it make sense to take everything that's on the bottom of this tank and sort it again? Or is it more efficient if you pre-sort already, if you don't shred the whole car, but if you dismantle larger parts of the car, like the bumper, for example, or a door panel, which then will be shredded and sorted, but where you don't have contamination with other products like, fuel tank or fuel line components or something like this. And these are these questions in terms of developing a closed loop in automotive that we need to tackle. But we can, if you leave us your email, we can of course get in contact and go deeper in discussion here. Maybe you also have an idea or do see a chance to start a project here.
Let me just add, Knut, for mechanical recycling is absolutely what you say. So this is in development. For chemical recycling, there is the tire pyrolysis. So this is an existing opportunity to bring it back. If that is then at the end accepted as automotive to automotive, we will see, but that will be then subject to regulation. Good. So then lively discussion, actually. We have quite some questions still. Question relating to biofeedstock. Everybody talking about UCO, used cooking oil. Are there or will there be enough UCO or similar feedstocks on the market? So I like used cooking oil because just the imagination, it's so concrete. So, actually, what we mean is biocircular feedstock. So this is what ICC Plus recognizes as biocircular, and that can have different origins, and UCO is just one of it. And actually, that market is relatively large. And then, as a second category, there would be biofeedstock. That is then a completely different thing. That can be vegetable oils that could have competition in food. But this is what we add in, I don't know, millions of tons to biodiesel today. So that is a huge market now. But already biocircular is a fluent market, a relatively big fluent market. And I would expect that there's enough for the foreseeable future. Good. Homogenization of the final batch is very important. Do you homogenize the produced eco lots, and do you have lot or batch homogenization steps before packaging?
Of course.
Very short answer. Okay,
same as we do with our virgin products. No difference in the way how we do the homogenization and how we do the packaging and the homogenization of the lots before. There is no difference in our production. So as I said before, from a point of view of the production people and the quality management system in our production sites, it is just another feedstock that goes to the compounding line, but it's the same compounding line, and they apply the same quality measure. They don't differentiate between an eco product or a virgin product.
Very good. Then we have a question on the tolerance of the percentage of PCR content in the same grade of material, lot to lot. I'm not sure if I
the Recyclass certification we are applying here, they require a minimum, let's say, percentage. So if we are talking about an MR30 with 30% of recycling content, there need to be at least 30% of recycled content in there. The upper limit is basically free, but this is limited by the product performance. So I cannot do a Novodur H605. I cannot put 40% of recycling content in there, because then I will not meet the lower spec limit of my Sharpie, as I was showing in the slides before. So the upper limit is basically limited by the product performance. The lower limit is limited, the lower limit is given by the Recyclass certification.
And I think the question was also to lot consistency. And I think honestly, if we say it is 30%, then it's relatively easy for us to adjust that it is more or less exactly 30%. So there is no big question around lot consistency. Yeah. Two questions which also go in the same direction. First of all, are your products recyclable? Also the eco products. Are the eco products recyclable? And then the second on top, and then you can take them together, Knut, is does repeated recycling reduce performance?
Probably yes, but we don't know yet. And at the end of the day, this is we are compensating with our recipe. So we, of course, the product we are receiving right now, the feedstock we have already has a reduced performance, which we bring up to the level of a new one and then bring it to the market, and there you will have a drop in performance as well. So it's a constant up and down. We're getting back something that doesn't have the performance level of a virgin product, and we bring it back to the old level. What does it mean if you have in 10 or 15 years more than 0.001% of recycled ABS in the feedstock we are getting back? We don't know yet.
Yeah, absolutely. I also would say we are today used to upcycle because the WEEE waste we get is not only waste but sometimes scrap. And therefore, yeah, this is the typical issue. So we need to upcycle, and we just do it then also. And moreover, this only would kick in, that repeated recycle thing, if we have really high and large recycling rates. So in the foreseeable midterm future, that's not the case. So don't worry, recycle as much as you can. Next question. Thanks for your presentation. How can you be sure about the flame retardant complete removal in your recycled materials?
Yeah, so this is basically one of the most important part here. The good thing is almost all of the flame retardant products that are blacklisted in automotive are having an effect on the density. So you can easily take them out by density sorting. And the rest is then also something we specify to our suppliers of these feedstock, because this is the important part for us. We do take a lot of effort also from the regulatory point of view to meet the requirements of the automotive industry and to fulfill as much as possible the requirement there when it comes to global automotive declarable substances list, for example, which is quite challenging when we're talking about things like PFAS. But that's a different story. That's probably a topic for an own webinar. But back to the flame retardants, they are quite easy to sort out, especially the ones we don't want to have in automotive.
Excellent. So that brings me to the very last question, and that is perfect because then we finish on time. How or with which technologies do you avoid metal contamination of feedstock or metal contamination in your recycled eco grades? Maybe you go first, Knut.
Yeah, density sorting and all the rest. We also have, if there is any metal coming through, we also have, of course, melt filters in place in our production to take out at least the biggest particles. You will never be able to avoid metal in a plastic material that's been compounded on a twin screw extruder completely, because the twin screw extruder, there is a friction between the screws. They are made of metal, so there is the risk that it comes through. Therefore, we have in our compounding lines the melt filters in place to take out particles, but only to a certain dimension. But the source, the feedstock, the recycling feedstock itself is also sorted. As I said, one of the first steps here in the sorting is the density sorting, and that's the big advantage. If you do a density sorting, you get easily out most of the parts or even flakes that have some metal contamination in there.
Yeah, I would add that actually the risk to have a metal contamination is not higher than in the virgin products. Yeah. We have the sorting, we have the metal filtration, and at the very end, every bag undergoes metal detection. And if there's any metal, I don't know, a screw or whatever detected, then the bag is put aside. So that's exactly the same process that we also have for virgin, and therefore the risk is actually not higher. With this, Knut, thanks a lot, and thank you to our public here for listening to us. I hope that was a good overview on where we are regarding sustainability, and there's quite a long pathway in front of us, and I hope that we can go this one together and drive the sustainability forward in the next years, probably. That will be with us for longer, I guess. Thanks for your attention, and have a great afternoon.
Also, many thanks from my side.